Okay, this is the calculus tutorial that you really have to know for your Calculus 1 class. And don't get this kind of questions wrong because you don't have to do any algebra for this. It's just the concepts. So first, we are given the graph of the original. So this is f, this is also f. And then we're going to answer where is the original function f. Increasing, decreasing, concave up, concave down, and also the points of inflections. So here we go. Let's start with the first one right here. Part A, where is the function increasing? And because we're just given the original function, so what you see is what you get. If the curve is going up, that means the function is increasing. So we see from 1 to 3, likewise from 4 to 6. And we just want the open intervals, so we write it like this. Parentheses 1, 3. Right? This means we do not include 1, and we also do not include 3. And then the answer in the back of the book, they use a comma, but if you have more than one intervals, I like to use a union. So it doesn't really matter. All right, the second one is from 4 to 6, just like that. Now, continue. Next, we are going to find out where the function is decreasing. So it will be from 0 to 1, and then from 3 to 4. Yeah, just these two. So let's go ahead and write that down. B from 0 to 1, union from 3 to 4. Now part C, where is the function concave up? So how does concave up look like? Well, just remember that as the happy face parabola. And remember, this is concave up. Likewise, that is also concave up. So be careful with these two pieces. So concave up, we see this part of the graph is concave up, but also until here, right? So that's concave up from 1 to 2. And then, where else? In fact, no more, because the rest is just concave down, right? Concave down. And let me just erase that. We see that the function from here it's concave down, and then from here to here it's also concave down. So firstly though, let's take a look at that piece. It's from 2 to 4, right? And then at 4, this is a sharp turn that the second derivative does not exist, and you just don't say if it's concave up or down. Just ignore that, just exclude 4. So union 4, and then you go to 6. Just like that. Lastly, E. So this is a little bit unfortunate because of the bad notation. The last part is that we are going to find out the coordinate. So you have to give the x and also the y value of the point of inflections. And we see we have a point of inflection here because the function goes from concave up to concave down right there, right? And you have to give a coordinate. So you say this is 2, 3. And to make this super clear that this is a point, I will label this as the x value and also the y value. All right, I think that will be super clear for that. All right, done with number 1. Now, go ahead and try number 2 before you watch the video. Before you continue. Done? All right, I trust you. Now, number 2, part A. Where is the function increasing? This is a little bit tricky, so pay attention. First, you go from here to here, so that's 0, 1, no problem. Union, we have another piece. We go from 3 to 5 like this. But notice right here, even though the function is flat, right? But it still continue to go up. So you really just count it as one interval from 3 to 7. Again, the question is asking where the function is increasing. Even though you have a horizontal tangent point right there, you still just consider that as increasing, all right? The best example for you guys is x cubed. X cubed looks like this, and x cubed is always increasing. But if the question is asking where is the first derivative is greater than 0, then you are not going to include the number 5. You will say 3 to 5, and then union 5 to 7. So increasing and the first derivative being positive, there's a slightly difference, right? Just that. All right, so that's the only tricky part in my opinion. Then the rest is pretty straightforward. Okay, part B. We want the function to be decreasing, so let's see, decreasing. So we go down from here to here. Just that, right? So 1, 2, 3. Okay, and then we continue. Concave up, concave up, concave up. So it looks like to me it's from 2 to 4. That's concave up, and also from 5 to 7. And the last number here is 7, of course. So for C, we have 2 to 4, and then another interval 5 to 7. Just like that. All right, how about concave down? Concave down is like this, right? And then we have another one like that. So 0 to 2, and then another piece is 4 to 5. Cool. Lastly, we want the points of inflections. How many points of inflections do we have? The answer is 3. One is right here, and the other one is right here, and the third one is right here. I'll show you. Have a look. It goes from concave down to concave up, right? So at 2, we have a point of inflection. Then it goes from concave up to concave down. So at 4, we have a point of inflection. Lastly, concave down to concave up. So this is also considered a point of inflection. All right. Again, we are going to give the coordinate. So the first one is 2, 2. And the next one, and these are points. You don't put down union for points. You just put a comma in between them. The next point is 4, 3. And the last one is 5, 4. And let me just emphasize, this is the x, y, x, y, and also x, y. So these are points. And the rest, like this, they are intervals. Unfortunately, they look similar in notations, but that's it. Hopefully this right here helps.